Hey everybody, how's it going? We've reached an exciting time. Probably be more exciting if I was all pumped up in front of you guys in class, but we've reached the point where it's time to review. So we've learned the new stuff we need to learn, and now the focus is just doing our best to get ready for this exam, May 22nd, I believe, 2 p.m. Eastern. I'm pretty sure for us. So let's do it. Right? I know it's tough, but let's push ourselves to prepare. And honestly, you're I hope you still want to succeed on the exam, right? We can still get college credit and all that. Um, like I said, and all that, like that's not a big deal. That's a pretty big deal. So you can still get your college credit, but this is going to come back to how much you put in individually. We were in school, it'd be a little different. I'd be harassing you all the time, being in your face, pushing you, and I wish I could be doing that, but obviously we're all home on our own, and as tough it is, just try to stay motivated here. Keep studying or pushing or whatever. Um, Obviously this year's exam, there's no multiple choice. So the best way to study is just do tons of free response. And so there's, I'll share some links. I've shared the link to all of the released free response from past AP exams. And honestly, that's the best thing you can do to study is just do tons of free response and score them. And so that's what we're doing this week, along with a little AP classroom multiple choice. So the one AP classroom assignment, just so you guys know, is about data collection. There was one question about data collection on the 2019 free response, but we actually did it in our notes. So you have that like cut out and glued in like back, when we had regular school and stuff. So that's why we're only doing 4 of the free response. But so this week we're going to do the 2019 exam, and rather than just having you read the rubric, I'm going to create these solution videos and we'll look at the scoring. And so that way, if you didn't know how to do something right, you get some explanation, not just looking at it on paper. It's going to be a little tricky because I can't write on the screen. I'm going to do my best. So let's get to it. So let's just jump right in. So this video, 2019 first free response. So this was the first question on last year's exam. It is quite possible, this could have been on your unit 1 test, right? We could have done this almost in the summer. So obviously, hopefully you've looked at this already. But if you need to, pause it and check it out, and then we'll just jump right in. One thing I recommend is I would read the whole question right off the bat. So you have a sense of everything that's coming. All right, I know I'm gonna have to describe this distribution. I also know that I'm given this table of information, which hopefully seems important for describing a distribution I might pull from. Then I'm gonna have to create a box plot, determine if there are outliers, and then just state what can I see in the histogram that I can't see in the box plot specific to the shape. All right, so read through everything first. You have a sense of what you got to do. Also on the exam, there might be more parts to these free response, right? So for this year with this weird exam, the 2 free response, it's possible, right? You don't have time to do everything, and that's on purpose. So there might be more parts than you can do. So that way there's a lot of different kind of places for you to show something that right? So, if a question was only about probability and you didn't know probability, then you can't show anything. But if whatever, if there's a bunch of parts, part A is about data collection, B is about describing data, C is some probability, D is inference maybe, right? You can pick and choose and show, right, your understanding in different ways. So read through everything, do what you know first. So jumping right in here. So number 1, we've got a histogram showing the sizes of 20 rooms in a student residence hall. And our job is to describe the distribution. And hopefully, when we're describing the distribution here, hopefully immediately, right in our heads, we're all thinking socks or cusps or whatever your teacher uses. Shape, outliers, gaps, clusters, center, and spread. So getting into those things. Let's start with the shape. Hopefully pretty clear. We got something like this. So although there is only one gap there, this is definitely a bimodal and fairly symmetric distribution. So that's pretty much it for the shape. So if I'm writing this up, I might start off immediately. We know we like to reword the context. We've used that a lot with our hypothesis testing, right? But that still works here. So we want to start out with maybe the distribution of room sizes in the residence hall. Notice I'm just taking this context, right? Distribution of room size in the residence hall and copying that is bimodal and roughly symmetric. So we got the shape. Outliers, gaps, clusters. Now, it doesn't appear that there are any outliers here, right? You never know, but we don't see any gaps or anything, anything crazy off to the sides, but we do have 2 clusters, right? So another, in terms of this O, this is really anything unusual. That's why some teachers use CUS. They use for unusual features for this acronym. but we do have two clusters, right, from 100 to 150, or we do have a gap from 200 and 250, right? And we want to say that in context. So maybe I say something like most rooms were 100 to 200 square feet, or 250 to 350 square feet, something like that. That's kind of commenting on the clusters in context. So then we get to the center. So for the sake of review, we might remember, hopefully, right, with a histogram, if we were only given the histogram for the center here, we're going to have to estimate the median. And so to do that, we do know that there's a sample size of 20. Right? If I cut that in half, that gives me 10. Now the median is not the 10th data value, right? Like if I have an even number of data values, like say I had 4 data values, when I do 4 divided by 2, right, that's 2, this is not actually the median. So the median is actually between the second and the third. So our median is going to be between the 10th and the 11th data values. And so some, if you look up some formulas, some use n plus 1 divided by 2. And so they would do 21 divided by 2. And that would give us 10.5, right? This is based on that n plus 1 over 2 formula. And I'm going quick, but right, hopefully this is all review. Right, and that would tell us that the median is, right, 10.5 is between the 10th and the 11th data values. So if I count that, here's our first 3 data values. Here's our next 6 data values. So there's 9. Here's our next 1. So the 10th data value is in here. And then the 11th data value is in here. So for the median, if we're going to just estimate from the histogram, we cannot give an exact value of the median. The best thing we can do is say that the median is somewhere between 200 and 300 feet, right? We can't even narrow it down to one bin. So I could write the median room size is between 200 and 300 square feet. I think I said feet by accident. But going back earlier when I mentioned reading ahead, I actually don't really have to do any of that work for this problem. That's all good and that's all correct. But for the center, if I go back to this slide, for the center, I have the numbers right there. So I could just look at this table and it's totally fine for me to say the median household size is 253.5 square feet, which of course is between 200 and 300. Or if I wanted to, think to yourself, what's another measure of center up here in this table? Right, we could have used the mean. So in this example, this, is specific to this problem, but we could use this extra information. Boom, there's 2 options for measures of center right there. If on the exam they don't give us a table like that, makes our lives easier if we, use that to our advantage strategically, that table, right, then we have to estimate the median as I've described in purple here. So similarly, for a measure of spread, I'm just going to erase all this stuff. For a measure of spread, if we're only given a histogram, we only have one option, and it's to estimate the range. Now, we can't give the exact range, so you cannot tell me that the range is 250 because, right, like there might not be any hundreds in this bin. Every number in this bin over here might be 149, and every number in this bin over here might be 300. So the range could actually be significantly smaller than 250. So we could say, for spread, we could say something like all room sizes are between 100 and 350 square feet, or we could give an interval estimate for the range. So going back to the range, because we don't have the exact values if we're just given a histogram, we can say the range is between 250, right, 350 minus 100. I'm saying it backwards, but the range could also be as small as 150, right? Because this bin-ish, right? Because this could be a 149. Every number in this bin, every room size could be 149 in here. And every room size, well, I mean, there's only 3 of them. These could all be 300s, right? And that would give us a range of 151, but whatever. So here we could say the range of room sizes is between 150 and 300. I'm sorry, and 250 square feet. Or I could say the range is at most 250 square feet. Right? So if we're just given a histogram, we can't give the exact range. We're going to have to give an interval estimate for it. But again, jumping back to this table, we could actually give the exact range for this. Now, if we said the exact range is 250, that's incorrect. Did I just make a mistake over here? No, I didn't. So we can give an exact value for the range, but it has to be based on this table. So we could actually just find the range, max minus min right here, and I think it's 181. Or you might think to yourself, what's another measure of spread I could reference from this table? And then that was like the worst Jeopardy song ever. Right, we got standard deviation, or we could bust out a little IQR action. Right, so use that table to your advantage. So what we have right here is perfect, or if I wanted to, right, I could get rid of all this. I'll just make it italicized. And if I want to, instead, I could write this purple italicized stuff. I could say the median room size is blank square feet, and the range of room sizes is 181 square feet. And the only reason I said the blank is because I forgot the two numbers that were on that table, right? But you could calculate the exact median. All right? So socks. Don't forget, shape, outliers, or any weird stuff, center, and spread. So let's see how we did. So to get essentially correct, we need shape is bimodal, or we could have said there's two peaks or two clusters. We kind of did both of those things. So we got the bimodal part. Center is between 200 and 300. We did that with the median. We looked at how we could do that using the table. And I did check the rubric. It is okay to use numbers from the table, right, or estimate the median. Spread has to be between 150 and 250. We looked at that. Or, right, we could give that exact value from the table. And then, of course, we're always going to write in context, right? So we got a nice E there. All right, moving on to part B. So part B, got our numbers, right? We just referenced this table. Determine if there's potential outliers, and then using the grid to sketch a box plot. So I think that a lot of my students in 2019, sorry, I'm reaching down to grab a board. I think there's probably a lot of students who got partially correct here, because I think there's a lot of people who didn't address, probably a lot of people, I don't know, I didn't see their exam, who didn't address this, right? We got to specifically state if there's outliers or not. Then we're going to use that information to sketch a box plot. So let me jump over to this. So this is just a sloppily written, version of that table. So outliers, right? Are there outliers? Yes or no? And we got to answer it. So if you remember, we got to calculate the formulas for our fences. Now this year, wait a second. Cool. Sorry, just making sure that I was actually sharing this. For this year, right, we have our notes, everything's at home, whatever. It's going to be super important to organize your notes for this exam. But hopefully we recall, right, Q3 plus 1.5 IQR and Q3 forgot to speak English, man, it's Monday. Q1 minus 1.5 IQR and Q3 plus 1.5 IQR. So for this, we're going to have 174 minus 1.5 times something. And for this fence, we're going to have 292 plus 1.5 times something. And that's something. Got to get our IQR. Remember, our IQR is Q3 minus Q1. So the IQR is going to be whatever 292 minus 174 is. Maybe a little something like 118. All right, so the IQR in here is going to be 118, and that's how we get our two fences. What am I doing? Why do I have so many measurements? So 292 plus 1.5 times 118. If you're wondering, that's what I'm doing there. So this is 469, and then 174 minus 1.5 times 118. Gives us -3, probably not going to have a negative room size. Now remember, these numbers are not data values, right? That can't be the size of a room. Are you crazy? So these are, right, that's not an outlier. These are the boundaries that determine, that kind of separate outliers from the rest of our data. So anything below -3, which is impossible, would be an outlier. Any room bigger than 469 square feet would be an outlier. And so if we look at the top, back at our table, right, the max is not bigger than 469. So there's, right, that's the maximum. So there are no values bigger than 469. So there's no high outliers, none on that end. And then the minimum is 134. So obviously there's nothing less than -3. So there are no outliers. But on the exam, right, we would have to say there are no outliers in this data set. Right, got to actually answer that question, please. So there's our math for that. Now we got to make the box plot. If it helps, going back to those fences, so what we're saying is this would be 400, so 469 would be like on my table over here. I really hope that comes off. And -3 would be like on my table over here, way over there. Hopefully that comes off, right? So anything outside these boundaries, my hands, would be considered an outlier, right? That's why they're called fences. So if it helps, you can use those little dotted lines to visualize. But now hopefully we remember how to make a box plot. So our minimum is 134, which is going to be about, this is 120. So there's our min, 134. Our box, remember, is Q1, median, and Q3. So here's our Q1, which is 174. The median, this is 240. So here's our median, which is 253.5. And then Q3 is 292, which is going to be over here somewhere. If I made a mistake with any of those numbers, it's because I can't read my sloppy handwriting, and I apologize, but the idea is the same. There are no outliers, so there's no separate dots to plot. Remember, if there were outliers, they would get plotted as a separate little asterisk. And then our maximum is 315, 365, 315, sorry. Can't read my handwriting. So that's going to be right here. Remember that these arms reach to the highest and lowest numbers that are not outliers. So if there were outliers, there would be separate little dots out here. The arms do not reach to these fences that I already regret drawing on this table. All right, here's our box plot. Want to make sure to label this, but of course on the exam, right, it was given, that axis was given, right, and pre-labeled. So that's that. So let's see here. Essentially correct. Compute the fences with, formulas or values substituted. We did that. Correct decision regarding the presence of outliers. So this is what I think maybe last year some of my students might have left off just because they didn't actually, I don't know, they might have just not explicitly answered that and just created the box plot. But we did say there are no outliers, and correct justification that compares the data with the fences. So like right now, we did not do this. So let's do that. What does that mean? That means to give a little explanation. Oh my God. I just realized I wasn't sharing that the whole time. So here's what I was actually looking at. My bad. So we got the computation part. We got the decision. So for here, we got to like actually say that there are no outliers and why. So here, there are no outliers in the data because there are no values below -3, right? The minimum is 134. Or valued. So there are no values below -3 or above 469. Right, the max is 415, 315, 415, 365. Do I even know what I'm talking about? 315. I do know what I'm talking about. And now we've, right, compared data with fences. All right. And then number 3, or part C, hopefully no big deal here, right? So we created this box plot. Here's our histogram. And so the question is, one thing I want to point out, right, is it specifically says what characteristic of the shape. So like mindlessly, someone might want to tell me, hey, you can see outliers in a box plot, but not a histogram. Like, and that's true, but that's not really about the shape. So what can we see about the shape here that we can't see here? And hopefully we realize that we can see the bimodal nature or the clusters, right? A box plot doesn't allow us to see gaps or clusters in our data, right? It's just showing summary stats. So we can just write, we can see that the distribution of room sizes is bimodal in the histogram, but we can't see that in the box plot. And if we jump ahead to our scoring rubric, right, essentially correct is just, oh, they lumped two sections here. I forgot to say lump the box plot with this. So you need the correct box plot. We got that. And then just saying we could see the bimodal shape in the histogram, but not the box plot. That's it. And then we got a perfect score, and then we get like a 5, and we celebrate and all that, and and call it. So see you guys for the number 3 for your response. Sorry, I'm so bad at talking. Peace.